Assalamualaikum warahmatullahi wabarakatuh. Hello everybody, how are you today? I hope you are all doing well. My name is Alsa Salsabila, can be called Alsa. I'm a college student at the Faculty of Civil Engineering Class 3A. In today's video, I wanna explain you about how system works, especially in civil engineering. What is that? The name is elevator. Elevator, also called lift, car that moves in a vertical shaft to carry passengers or freight between the levels of a multi-story building. Elevators are generally powered by electric motors that either drive traction cables or counterweight systems like a hose or pump hydraulic fluid to raise a cylindrical piston like a jack. So how do elevators or lifts work? When you press that call button, a command is sent to a computer controlling all of the elevators. The computer determines which of the elevators is moving in a downward direction and is closest to the ground floor. When the selected elevator car reaches the ground floor, the computer commands the electric motor at the top of the elevator shaft to stop gradually. Once the computer senses that the elevator's door and the lobby door are at the same level, it commands electrically powered arms to retract both doors. At this point, you may enter the elevator car itself. By pressing the button number 20, you have now sent an order to the computer controlling all of the elevators. The computer knows you want to reach the 20th floor, but what it actually does is use magnetic or optical sensors to count the number of dots on a long tape positioned on the side of the elevator shaft. When the car has passed enough dots, the computer orders the electric motor turning the winch to stop. Elevators use steel cables and a powerful winch to lift or lower their cars. To reduce the amounts of energy needed to overcome friction and gravity, elevators also use heavy steel plates as counterweights to the passengers' cars. These counterweights are attached to the other side of the steel cable loops and generally weigh about 40% as much as the maximum load limit of the passengers' cars. When the passenger car goes up, an electric motor turns a winch and the counterweights fall towards the ground. You must have observed this one. You can see this thing on ground floor. Whenever an elevator is at the top floor, when the lift starts coming down, the counterweights starts moving upside and vice versa. But why do we need it? Imagine, the lift has to go up on 20th floor now being on ground floor, and it will require 1000 kg of energy. What the smartest have done? They have joined a counterweights on the other end of the cables. Now what happens? The electric motor above requires less energy to lift you because our friend Mr. Counterweight is already helping us by pulling us up, which means instead of 1000 kg, this time you would need less amounts of energy like 500 kg, thereby consuming less power. There you go. Once The elevator's computer has since you've reached the 20th floor. Electric motors upon both the elevator and lobby doors. If you should happen to hesitate between the doors, mechanical and electrical sensors should prevent the doors from closing. If there is no elevator car behind a lobby door, the lobby door should not open. Elevators have a significant number of redundant system and safety features. If you should happen to hesitate between the doors, mechanical and electrical sensors should prevent the doors from closing. If there is no elevator car behind a lobby door, the lobby door should not open. Elevators have a significant number of redundant system and safety features built into them, including emergency brakes, call boxes, and shock absorbers. The chance of elevators snapping all of their cables and plummeting to the ground are virtually zero. And last, the conclusion is the concepts behind the elevator has been around for thousands of years. So today's modern elevators work just like a pulley, which is one of the 6 simple machines you may have learned about in science class. The elevator car that you ride in has a strong metal cable attached to the top of it. That cable runs up the elevator shaft and over a shaft which is like a pulley wheel with grooves that holds the cable securely. Computer algorithms. The elevator car that you ride in has a strong metal cable attached to the top of it. That cable runs up the elevator shaft and over a shaft, which is like a pulley wheel with grooves that holds the cable securely. Computer algorithms are used to make the elevator system work efficiently. Elevator systems can even be programmed to provide more cars to certain levels during peak demand times based upon usage history. I think that's all I can tell about how elevator systems work. Hopefully this video can broaden our horizons. I'm sorry if there is still a gap in this video, and thank you for watching. Wassalamualaikum warahmatullahi wabarakatuh.